everyone. Sorry, let me just let the people know, and then we're pretty good to go. Okay, cool. So previously, I worked yesterday. Yeah. So a bit of a some background. Yesterday, I was working on this. I mean, if you're on this video, then you've seen it on the thumbnail and everything. But I was working on a driver for this I2C to SPI expand bridge. We've done the I2C to SPI bridge part, and right now I'm trying to finish up the I2C GPIO expander part. So what I'm intending on doing today is I think I had some good results yesterday because I got it to run a test that failed with let's see. So we want to do a source vn dot virtual env bin, and then I'll activate that. And then in here, I think if I do this and I do west dash t, okay, whatever, do dash t. Yeah, so I can do scripts twister. Yeah, this is the one I want. I want to see what happens here. Yeah, I'll just show how the thing is breaking, and then we can kind of start fixing based on the broken tests, and then we can go from there. It's quite easy. I think it's quite easy. In the meanwhile, let me open up some. I'll go open up the datasheet for this thing so that we can have actually the reference that we need to do when we work on it. Yeah. So today's session, I didn't explain that much, but we're just gonna jump in and try and finish the driver that we started yesterday. This is kind of a continuation of a stream from the other day. So cool. So let's actually go see what we can do. Yeah. Yep. Let's see. Has my test finished? Yeah, it's done. And I don't like that. That doesn't sound. This doesn't look good. It shouldn't pass. I thought it would fail. I expected some sort of test fail, but I'm not getting a test fail. Odd. Did something change? Am I on some sort of different branch or something? Git log. My word, my life. I mean, it's always so interesting because I done but not run. Zero failed, zero error. That is not what it's supposed to do. Yeah. Perhaps let's actually go find. Actually, I can just go up and see if I can find it. Okay, that's different stuff. That's from earlier. That's other stuff. Yeah, there it was. Somewhere here I should have it here. Because I made that branch and then I checked the version and then I did a West build. But I seem to have skipped straight into. It's not doing what I wanted to do. And Control R, and then what is scripts? Twister. Okay, cool. this is not, it's not doing what I wanted to what I expected to do. So well, let's do this. Let's actually not waste that much time and jump into Zephyr itself and find out how to how to do the test, because I need the test to fail so that I can actually use it to build up to the other things. So pardon me while I find out what I've forgotten again. Real engineers would probably remember how to do this and just get it done, but I'm just a guy who runs tests and forgets how to run them. Cool. Any questions so far? Does anyone have any questions at the moment while I figure out how to run this test? Run test with Twister. I do want to see that, and then I do want to please show me how you actually run the test. So not that one, this one. Test drivers build all scripts. Twister test drivers build all MFD. Yeah. Perhaps this one. Let's try this one. Yeah. No, this is not the, this is the wrong place. And I want to do scripts, Twister, and something like that. And then let's see if that actually just runs the GPIO. If it just runs the SPI one, that's cool. If it makes something fail, it would be nice. But I think this should be also GPIO. I don't know what -t, -c, and -t in Twister mean. Maybe this is a good chance to get familiar to the implementation. That'd be a good twist to the. You know. Let's try and jump on the Twister test. That's cool. Yeah, this is much better. This is much better. But it looks like it's running. Ah, yeah. So 0 failed. I would like to do this, but I would like to do, instead of SPI here, what if we try GPIO? Did I actually commit my file? I expect I did. I should have committed my file. I expect I did commit my file, so. Man, every day I try and do something, I discover an issue. Nah, I want the Zephyr one. Anyways, fine. It's fine. I'll just go in. It's still running. Should be good. Let's see. Let's look at the Zephyr one. Repositories. This is the pull request by the description of the video, so you don't have to do all of this that I'm doing right now. I'm just recalling where I am. Not really, not exactly recalling. I'm just. You will see. I think I'm doing PR GPIO. So yeah, this is the one, and I did add that file. Yeah. So let's look at the commits. I did have I added an overlay there, so it should do something. It doesn't fail. It's fine. Actually, it's running it all wrong. It's running it all wrong. I don't want to run this fast one, so what happens if I just remove all of that and this feels like what I was doing before? It's very odd because I did add it here. This commit should add a, yeah, it adds it here. So this should be tested because it's an test drivers build all MFD. So it should be tested, but it appears not to be. And this is because I don't know how to use Twister very well. And this is initially because the first time I tried to use Twister, I failed quite a lot about it. But yeah. Cool. So let's just remove all of the. Let's remove all the Twister out. RM, RF, Twister. Yeah, and then here. Look. Let's remove all of those. LS, and then let's maybe just do a clean one. Let's see if a clean one actually does something so that we can. Could be that I'm running on an old thing. That is insanely thoroughly odd. Bartholomew says this is mega good content. I don't know how you figure that. Yeah, what does dash T mean? Dash T, dash T, dash capital T. Thanks, Bartholomew. Tags. Specify tags which restrict by tag. The default does not do any tag filtering. Okay, cool. This is odd. It should not do this. I'm doing something wrong. Surely I'm doing something wrong. It should not. It should not. It should not do that. It should not just succeed. Yeah, it should not just succeed. So let's actually just go mess up something on purpose and do something like GPIO E, so that I just want it to fail because I want it to tell me that it's running that stuff, and I want to know that it's running that stuff in the right place. Hey, Bartholomew. Hey, dude. Yeah. Should we land Twister? Should we land Twister? Maybe we should land Twister. Maybe that's what this stream is about, landing Twister. One test configuration was built. Writing unit X unit report JSON report to that. Can we look at this? Can we look at this? Does this actually tell me what was happened? Because it doesn't say anything failed. So native sim JJK. There's nothing. So that actually. Why? Why does it not run this? And how come we got it to fail yesterday? Just a moment. I'm gonna go on YouTube and look at my video and see how I managed to make it fail. What command I used? Yeah. Why am I hiding this? This is bloody weird. I'm gonna watch myself on YouTube while. Anyways. So I need to find out what that test is that broke yesterday. Obviously mute. So I'm talking now, and I'm gonna go here, somewhere here. At some point we ran a test. Yeah, here. Yeah, I see it was failing yesterday, so there's something, yeah? Okay. I'll show you the YAML file for the test, yeah. What do you mean the YAML file? The overlay? Okay, cool. So that's it. Scripts, twister. That's all I'm doing. Scripts, twister, dash T, test, drivers, build all, MFD. Is it because I have it committed? That's all I'm doing. That's all I'm doing. How come that isn't working? Bartholomew, you want to look at this? Or what YAML do you mean? Is there another YAML? This test case? This one? Is this the one you want to look at, Bartholomew? Yeah, this one. Yeah, I know. You can choose test cases. The test cases? So yeah, here's the test case. It just covers everything, and I don't see a problem here. I feel like it just doesn't. It's like it's get branch. Yeah. One build, not run. One selected case, not run, built only. Yeah, this is very odd. Because this same test was actually failing yesterday. This is what we needed yesterday, and it was failing. So now I'm confused because I don't know why it's not failing. If you see here, just go ahead and fail. So this one errored case is what we want. We want that errored case. Yeah, Bartholomew says Twister works based on YAML files, and I guess the YAML files define test cases, and test cases are going to be when you're testing as testing out. Yeah, you see that this errors out. This so and it goes to a log somewhere out here. I wonder if it's because there was something committed or not committed. Its status. Maybe it just runs. This is very odd. Wait, West config money manifest the path where we Zephyr, yeah. That's the way it's supposed to be. That is where it's supposed to be. Yeah, so Bartholomew, yeah, this I'm expecting this is a YAML file you wanna see, the test case YAML file, and it covers that, and it just all the drivers in there. So I don't see what's happening in here. App overlay. Mm. Mm. No, this is not good. It's a very intermittent thing. Maybe let's pull and then git pull. Git read base main. Yeah, Bartholomew build. So first of all, where am I? Where am I selecting build only? I'm not even selecting build only. Oh, okay. I see. You mean in here, in the in here, build only. Yeah, I understand. Yeah, it's supposed to only build. It's true because right now we're just testing that it should fail already at building because it should not find. Oh, I know why it's failing. I know why it's failing. Here's why it's failing, Bartholomew. So this is what was happening yesterday. Um, drivers. I know why it's failing. We fixed it yesterday. GPIO, and then SC18. Yeah, because that exists. SC18. I1. It's because this exists. So if we go like 661, this will now actually okay, 1 and 2. This will now actually cause our test to fail. Here you go. Yeah, this will now fail. It's because we fixed it yesterday, so it doesn't actually it it doesn't actually fail. No, it's gonna fail. So we did fix the reason it was failing yesterday. That's what I'd forgotten. That we actually added a fix, and it because that compat exists, and yeah, yeah. There you go. Cool. So that's actually what happened. It did. We did fix it yesterday. So the issue was that I forgot that we had gone that far ahead. So that's fine. So number one, let's actually close this. That's weird that we have the stream open on the stream, and maybe we see whether. Yeah, I don't see how you go past this. Um, let's perhaps look into the let's before we come back. Okay, first of all, let's just get in here and then Control A, Control E. It's there, and then I want to go back here and look at explore this test a bit. So maybe Bartholomew has a yeah. So you see MFD. Maybe Bartholomew has a project here. So there isn't much. Oh, this is where I want to go into source, into main. Yeah. So even if you go more than build, there's nothing in the main that you can do. So I don't know if that makes any sense. And at this level, the test is to actually just check that I have everything that is included so that it builds. And I think if I run it again now, here's an error. If I run it again now, it's gonna work, and we basically can go on with the development right now. So now we need to find out. First of all, we need to do some. I don't know how to implement a GPIO driver, GPIO controller driver. I have no idea how to implement a GPIO controller driver. So I lie slightly. I know how to implement it. Okay, cool. So what do you want now? I want to go here. Yep. Um, um, so first of all, let's rename that and this. So I lie. I know how to implement a GPIO driver, but I don't know how to implement a GPIO driver in Zephyr. Okay, I know how to implement a GPIO driver in bare metal for right now for an STM32, for almost any STM32, I should be able to implement a GPIO driver. But I don't know how to implement Zephyr GPIO driver, and I think we're going to use this as our hint. This one. We can be clever and do a split. I don't like doing a V-split like this, because if I do a split like this, then you don't know where I am, and it's like kind of weird. That's fine. So we can be clever, and we can just I'll open this in the browser, and then we can jump between the browser and this one. It's much easier, so that you can, it's easier for everyone, and I also know when I'm referring and when I'm actually writing code, so that's fine. So that's okay. So let's go out here, and we can open the SC1 8IM. Yeah, this one over here. Let's open this one. Perhaps even look at the latest one if possible. Can we see the latest one, so I don't have to like deal with anything? Yeah, just on main, in case something changed last night and I'm unaware, and I need to deal with it. So yeah, this should be cool. It's fine. We'll deal with it as it is. Yeah. Okay, cool. So let's actually go through this. So we did a GPIO config. It's a common. Why does this need to be fast? Because I don't know. We'll find that out all together just at the moment, and then we'll go and push this all out quickly. So let's actually start doing this. Again, as I said yesterday, I'm remembering this as you guys are watching, so I don't know what I'm doing most of the time, but we'll figure it out. This is easy enough to figure out. So we need error number, why I don't know, kernel device init. Why do we need init? I've never used init. Drivers GPIO, driver GPIO utils, logging, logger, and then we need to include. This is why the CMake was weird, because usually in a driver, like, so if we go something like here, you'll see it doesn't have any other header. It doesn't include a header of itself. It just includes Zephyr headers, Zephyr stuff. But this other one does include another I2C. You see, it includes I2C, I2C that, and that's where that header resides. I think we're going to include ours from SPI, because our driver exists in SPI. And I don't know where he's using error no. Pin configure. Oh yeah, so this is just the basic stuff. Pin get config. Okay, read the config. Pin port get row. Cool. Port set mask row. Port set bits row. Port set. So whenever you're building a GPIO driver, you can go to this Zephyr drivers GPIO. So let's go. Zephyr. I want to find that file so that we can look at it. I know where to go. It's in include. You'll see now. It's in include. And I think it's going to be GPIO. Ooh. Okay, drivers, yeah. And then here it's going to be GPIO. Cool. And then something like just GPIO.h, GPIO common, or GPIO something.h, GPIO common. I expected GPIO. So maybe it's actually an include itself. Could be down here. I'm a little confused. So let's see, where do we find this? Zephyr drivers GPIO.h. So it should be somewhere in here. So just plain GPIO. In any case, there's a file that's going to tell us the minimum amount of callbacks that we need in order to implement a GPIO controller. And yeah, so let's look at Zephyr API documentation. I should do something on, I should learn Twister soon so I can keep up with Bartholomew, but I'm different thing. Sorry about that. So let's actually go to GPIO and yeah, GPIO.h. So yeah, GPIO.h, and I think go to the source of this file, and here you'll find the minimum. There's a point where it goes like, these are the functions you need to implement so that you have your driver, and it's in the device section, so device API or something of the sort. There's a place where it will tell us like this is the minimum you need to implement. The other problem with GPIO is that it does not have well, it's not really a problem. It does not have a maintainer. GPIO does not have a maintainer clearly. So we just do what we can. So it should say something like so these callbacks need to be, these are the callbacks we need to implement, but there is a minimum list of callbacks that we have to implement in order to have GPIO. No, there's a data structures. So not data structures, not macros, not data structures. So ever close that. Anyways. Yeah, something like this. You need to, these are the the functions you need to implement. So here it is actually. If we go down here, you're going to see them. Here, device API, pin configure, and then I don't know if it, pin get config, and then port get row, port set mask, port set bits, port clear bits, port toggle bits. There's a list that shows us the minimum amount somewhere on Zephyr. I'm just let's actually do that. Just look for pin configure. Let's go to Zephyr itself and we search for pin configure. Pin configure. There's a minimum set of functions you have to implement to follow a driver. Without access to hardware, native sim, you can write code on native sim. You can you can just you can use native sim as your board. It's a simulation and emulation, and then you can also write emulators. That's as far as my experience goes. So Bartholomew is asking, do you have experience testing with Zephyr? Do you know how to write code without access to hardware? What does Zephyr offer for testing code without hardware besides UT? I don't know what UT means, but do I have experience testing with Zephyr? Precursory experience. I can run tests on Zephyr. I can run Twister. I remember I tried to learn how to use Twister for testing, and I realized Twister was it needed you to write a test app all the time, so you have to make an application to test, and that's sort of what I remember. Do you know how to write code without access to hardware? Yes, there's two options to do this. You can test on a native sim, so that you can use you end up using the peripherals on your development machine as the peripherals that you need. Say you need I2C, you can use the I2C on your machine to emulate some other I2C, and then you can see how it works. And then if you really want to do it, you can do emulators. And then, yeah, an emulator plus Twister, you can write unit tests. But they're not as clear as you think they are. It's not the kind of like unit testing I know I came into Zephyr thinking I would get unit tests like I have in normal code. Like I have when I'm writing, say, systems code, and I can run or I can run all these unit tests where I have like these assertions and such. And that's not how Twister works, really. Twister is sort of like this. We'll look at it just now. Let me find the thing I was going to say, and then we'll look at it. We can look at Twister. That's fine. I'm okay with that. But the way you want to do most testing is something with like you can write an emulator and then you can go with it. Yeah, there's a list. There's gonna be a list somewhere. Drivers. There's gonna be a list somewhere that tells us the list amount of things that we need to implement so that we have a GPIO driver. I forget where to find it. I really forget where to find it. I know sort of where to find the video one. Yeah, Twister doesn't exactly use Kemu, but you can use Kemu. I don't know the food word of Kemu. I don't know if Kimu. I don't know how you say it, but yeah. We'll look at Twister just now. It seems like that's what we should look at. Cool, but let me find the thing I'm trying to look for. Are you guys ping ponging questions between each other and go like, yeah, you go ask that question? uh, okay, no, I don't want anything. I don't want the string pin configure. I want to go like space pin configure. Yeah, come on, give it to me. There's a place. I don't remember where. That's the problem with me. I don't try to remember. It's like in GPIO.h or something. Wait. Before we keep going, I knew I made a mistake when I moved away from GPIO. Up to me. So I want to find I think let's find GPIO.h. But we already looked at it. GPIO.h. But it's fine. And the problem with finding GPIO.h, it's probably an auto-generated file. Is it an auto-generated file? Oh my word! Whenever I want to do something easy, it just Nathan and Bartholomew make it so hard. Yeah, but that's the one. Let's actually go. It's cool. It's fine. We're gonna find it just now. So video.h. I know this one from video. So let's go for video.h first. Yeah, so this include Zephyr drivers video. That's fine. So we'll go look at that one as well. So I'll show you what I'm looking for. I know about it from video. So if you go somewhere down here, it will go like this is the minimum amount of callbacks you need to implement. And if you do that, you have a video driver. So where is this thing? No. F F set FMT. Yes. See. Ha. Here's what I'm looking for but for GPIO. Subsystem struct video calls. Mandatory callbacks. This for optional callbacks. That. So I want to find the same mandatory callbacks for GPIO. And clearly I'm in the right place. So drivers, so let's go back drivers and then let's go find GPIO. And the problem is not all maintainers actually write what is mandatory. So sometimes you don't even know what is mandatory, okay? Sometimes you don't even know what is mandatory. Come on. Now my mouse is dead, obviously. Why couldn't I choose an easy life? I could be the guy who streams listening to... I could react to people riding bicycles. I'm getting pretty mad right now. Okay, cool. Relax, Zach. It's okay. It's fine. It's fine. So, GPI Intel, So, where is GPIO utils? GPIO H? This is confusing? Well, surely then this is confusing. GPIO.h. I found them. So let's go look for the mandatory callbacks. I saw this was Control F and then go like that. Subsystem. Aha. Subsystem struct. This is it. As you can see, they don't say which ones are the mandatory ones. And that's the problem. We don't know which ones are the mandatory ones. But I don't know if we're going to actually have to implement all of them. So, let's give this one a break. We're going to come back here. We're going to anyways implement this. This is not a problem. We're going to write this code. It's going to work. It's fine. I feel like there's a lot of curiosity with Twister. So let's actually go and look at it and then try and learn what it is, and then we'll jump back to writing the code we want to run. Or maybe we'll do that. We'll do whatever we want. It's our stream anyway. So let's look at testing. Testing in Zephyr. So Twister. Oh mode. Yeah, let's look at it. So test framework. The Zephyr test framework, Z-test. So there's Z-test and there's Twister. And Twister, one of them is a part of the other. The Zephyr test framework provides simple testing framework intended to be used during development. It provides basic assertion macros and generic test structure. The framework can be used in two ways, either as a generic framework for integration testing or unit testing specific modules. Okay, cool. Using Z-test to create a test suite is as easy as calling the Z-test suite. The macro accepts the following arguments. Suite name, name of the suite, predicate of the suite, and is there a sample? But we'll find out. Predicate of the suite and the setup function and the run before, run after, teardown. So if you guys are asking about unit tests, you know all of this. So cool. Below is an example of a test suite using there you go. Set suite, alternating suite. That's it. Adding test to a suite. I want to see a sample. Let's look at a testing sample in Zephyr. So we found the GPIO.h. We don't really care about that right now. It sounds like we care about tests. So there's a few ways of testing, and they're both being asked about in here. So Nathan is talking about simulation emulation, which is when both of you are talking, both Nathan and Bartholomew are talking about simulation and emulation. When you say you don't have hardware, it means you want to test some I2C code and you don't have an I2C peripheral right now. So you go and you emulate or simulate that. I used to know the difference between emulation and simulation. One of them is like pretend like, and the other one is one. Is one of them pure software and the other one not? What is the difference between emulation and simulation? Uh, let's see. So, let's see. Some good answer here. Emulation is a process of mimicking the outwardly observable behavior to match an existing target. The internal state of the emulation mechanism does not have to accurately reflect the internal state of the target which is emulating. Okay, cool. So emulation is something like mocking. A sum function should, if you give it a and b, it should give you the sum of a and b. It does. So you could have like, you could have canned values. So you could have a function and you need to give it like an integer and another integer, and to emulate that function you can just pretend. You don't have to follow it in internally. And then simulation is where it does the same thing that the hardware does, but in software. Okay, so you model all of these things, and if I understand correctly, we have emulation in Zephyr. I don't know if we have simulation. I'm sure someone has come up with it. This is large, absolutely huge open source projects we're talking about. So there's someone sitting somewhere with some simulation thing for Zephyr, and they have that and it's working. So first of all, that's what it is, and then let's now look into the test framework. Let's go back and see if we can find Zephyr samples. Let's see if we can find a sample for testing. Maybe that's what I hung about doing today. And I wonder how that's gonna be. So subsys, sysbill, I'm looking for testing. Application development maybe. External lib, application development, no, that's fine, I don't see that. Arch, basic, Bluetooth boards, drivers, net, subsys maybe. I don't think Twister is a subsystem. Testing is not a subsystem either. Test suite, perfect. So what does this do? Oh, so let's go into them. So let's look at integration. Yeah, you see, this still uses native POSIX, so I'm not so sure. So test case, same. This is only build only as well. Cool. Then integration one. And what does this do? I bet you not very much, but Nathan isn't. So you can just put a sats in your code. That's what we have for testing, and then this is a test suite, and then it's just an sat. Nathan, isn't virtualization basically simulation? Because on virtualization you're trying to implement all the internals as well. So virtualization is going to be simulation then. I don't know. Yeah, I don't know. I'm not so sure. Someone has to tell me. So cool. Here's a test framework. So they don't tell us how to run it, but we can maybe figure it out. But what I'm seeing is, I am aware that it is quite difficult because I've tried this. This is my natural way of developing is to write tests first and then write the code. And I know I don't do it here because it's not that possible. It's not as possible as you think. And then sometimes you need to, there's people who, I can kind of see it now. So you can't run these assertions on, you can take this integration test and I can see it. So we should try and run it. We should try and run it. We should try and run it. Because why not? Do I want to use native sim? Yeah. West build dash b native native sim, and then I want to do samples, and then I want to do test suite test. Where are we now? Sample subsys test suite integration. Yeah, it needs to be pristine. It's not as straightforward. That's what I remember. It's not as straightforward as we think, because it's not a matter of like, oh, you can just run all your tests without hardware. Sometimes you need to put the test. I know people who run their tests on their hardware, which when I'm looking at this, it's just putting assertions around statements. So you're not really making a separate test suite. You're sort of making a test application, and then you run that test application on some hardware that you actually have, and then it reports back to you, and then you can use something like native POSIX. But let's see how this runs and see what happens. And anyways, there's no readme here, so it doesn't tell us what to expect or what to do. That is a problem. So where is it? Did he give me something? Linking C executable, generating files, blah blah blah, standard boss, and sim. Where did you put this? I think it's usually in build Zephyr. Yeah, Zephyr.exe. Yeah, so you make an application. You can test it like this with we said this is an emulator with an emulator, or you can run this same sort of same application. Shall we run it on some hardware? Yeah? We need hardware that reports to console. Anyways, so let me get some hardware and we can run it. Where's my new favorite SD board? Yeah, so let's run it on this. I hope I remember how to run code on this thing. It's really hard sometimes. Let's actually run it on this board, and this is now not in development mode, so Control Shift T, and then I want to do Control R, Control R screen, Control R screen, clear, R screen, screen TTY, dev TTY, yeah, 11.5.200. That should be something. And then if I reset this guy, we should get some logs. So cool. So that's fine. We should get some logs. So what we need to do now is put this guy in bootloader mode. But I don't remember Nucleo N6. Nucleo N6 560. You see, this is the thing. I don't even know what I'm working on most of the time. So let me just come back here and do some shit. Make sure I know the board number so that we can actually use it. I want to do this one. Yeah. Copy. So if I come here and I go build the same thing, okay, and then I need to to put this guy in bootloader mode, if I remember correctly on how to do this. Yeah, I did manage. Wetware. Like, you mean, can I run this? Can I run this test in my brain? Is that wetware? I don't know. I'm not so sure. That's funny. I think because wetware to me means a brain. So how do I run it on wetware? How do I run it in my brain? Just pretend like I ran the test. This is good. This is good. This is good experimentation, I think. So let's build it for this board. We've already run it. You remember we ran it on somewhere here, and we saw what happened. So let's run it on this board and see what those logs give us. Yeah, let's actually run it on this board and see what those logs give us. It's the same thing. Basically, what I'm saying is, you either emulate the hardware or you run your actual tests on hardware. And for me, this isn't actually unit testing, because unit testing means I write a separate set of tests and then I can just run them somewhere. You know, that's what unit testing means to me. But this doesn't feel like unit testing, because somehow the emulation or the simulation, it's... Oh, is Michael Levin that guy who has Neuralink? Okay, let's West Flash should just go swimmingly okay. This should just work by itself, no problem. And then yeah, so if I go here and I do this and I do the other one, and if I reset it, I hope both of you saw that, Nathan and Bartholomew. So I ran the same test on native sim and I ran the same test on hardware, and it just gives you the same result. So you either have to emulate an application, or you have to write your code with assertions and then run it on the hardware, and then you get the same test result. Does this make sense? Nathan, Bartholomew, does this make sense? I'm going to use that moment to just... Who is Michael Levin? Neuralink. Tell me if you want to see my terminal again. Oh, okay. All I know is wetware means brains. Wetware means physical brains that was made by evolution. That's what I know about wetware. And Michael Levin seems to be... I can optimize it to the point that Twister plays it on hardware. Well, we just ran test on hardware and we ran it on emulation. I'm confused. Well, okay, first of all, we've already done that test with framework. We've run a unit, and it's just normal assertions. It's just normal assertions. Let's see what I'm gonna see what Bartholomew means by... I'm gonna close the test framework and I'm gonna look at the test runner. Twister, yes, you can run... Bartholomew, it's a little confusing. In the first question you asked, do we know how to run tests without hardware? But now you're saying we can optimize it to the point that Twister plays it on hardware. So you want Twister to run your tests on hardware? Because we just ran Z Suite on hardware already. So here it goes. Twister scans for the set of test applications in the Git repository and attempts to execute them. By default, it tries to build each test application on boards that are marked as default in the board definition file. So it just tries to build the test application. The default options will build the majority of the test applications on a defined set of board and will run in an emulated environment. So this is back to Nathan's thing. It will run on native POSIX. I'm so confused. What is this and what is that? You have to be explicit. You're speaking to software engineers. You cannot be ambiguous. So let's see. Let's see if there's a test we can run on hardware from Twister. This should have something. Run test on hardware. Oh, okay. Oh, okay. Yeah. Okay. So you can use a test run on. Yeah. Okay. Cool. Okay. Fine. Um, okay. Cool. So do you want us to do that? Let's see. Yeah, but that's just running. But no. Just let's figure it out. Running tests on hardware. Besides being able to run tests in Kemu and other simulated environments, Kemu is a simulation, not an emulation. Cool. Twister supports running most of the tests on real devices and produces reports for each run with detailed fail pass results. So, if you want to run scripts Twister device testing, device serial, we can just copy this and change our device and see what happens. I mean, I'm not scared. I'm not scared. Okay. And then this is going to be. Oh, come on. Just give me a nuclear something. Yeah, that. Nucleo N657057X0-Q underscore Q. So Nucleo N657X0 underscore Q. Test kernel. Yeah, we are in ACM0, yeah. Let's see. Mm. Which one was the FRDM one? Do I have that? K64? No. Um, hmm. Is there a Twister sample? Yeah, but that. Okay, but. Okay, but. No. That's running on multiple devices, no? Hardware map. Yeah, you're talking about this. Executing on multiple devices. To build and execute on multiple devices to connect it to a PV. To just. Okay, we can do that. We can do that. If that's what you want. Fine. And then what? I'm just gonna copy it and see what happens. It's gonna explode. I know, because unknown is not a problem. Unknown is a problem, but let's see. It's not gonna like it because it's unknown. Oh, this actually won't even work because I have to put my thing in bootloader mode, I think. My machine is overheating or something. I don't know if you can hear that. Cool. I wonder how this fails, or if it fails at all. It must fail for sure, because because my my board is in bootloader mode, and you can't use it if it's in bootloader mode. You can't run the app if it's in bootloader mode, so it won't go anywhere. It's gonna crash probably or something. But let's see how it crashes. In any case, this is how you this is that's how you test. I guess that's how you run tests. Um, we use a lot of unit testing at work, but most of our unit testing isn't based on Twister or yeah, yeah. I expected that. I expected that, so that's fine. It's it's failed. It's failed. Um, it's not gonna work because this board works very like you have to be in bootloader mode and then not bootloader mode and then all of that, and then now we should have all the stuff in it. But yeah, sure, yeah. But we see now you can run tests on hardware. I mean, you can run them on hardware. You can run them on using Z Suite, and you can you can jump all of that stuff. But I think the one of the one of the best places that really benefits from Twister is CI when you're contributing to the actual operating system, and then once you're doing that, you can it's quite fun because you can when you're contributing it, then you can test your stuff without doing the other stuff. I'm yet to find a way of just writing unit tests and building all your code without either emulating or simulating hardware. I think at the end of the line on every part you still need to emulate or simulate hardware. What I want to go find out now is how do we implement this GPIO driver. So let's try and implement this GPIO driver because we got distracted. You need to add this board to your YAML file in tests as platform allow and integration platforms. So we can't do that, but I don't. Yeah, I'm not gonna do that right now. I don't have a problem doing it, but I don't want to do it right now. We can't do next stream can be only Twister if you want. Let's see. And as platform allow and integration. So where was I running that sample one? It's tests samples hello t tests. So in tests, is there sample in tests? Is there samples? Okay. Yeah, I don't see that one. No. No. So I don't see samples. Does if I go into samples themselves, will they have a test case in them? Basic. Which one is this? Which one is it? Hello world. Yeah, let's see. Maybe the hello world sample has a test case in itself, and I've always been ignoring it. So samples. Maybe it does. Maybe it does. I wouldn't be shocked if it has a test. I don't see a test case. And let's look at the sample and description. Blah 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 blah. Tests. Samples basic hello world tags introduction. So inside tests, we should have samples somewhere. I don't see them. And still using native sim and all of that stuff. So integration platforms, you're saying here I need to add platform allow. Number one, where's platform allow? I don't see a platform allow here, but it should be somewhere. Integration platforms, I need to add dash nucleo N657. Is that what you're saying? We can look at this later. I mean, I need to come in. I'm not even gonna prepare. I'm just gonna do it here. But the problem is I titled the video something else. So it's cool. vsim, kernel, lib, misc, modules, net, robot. No, subsys. It's fine. I don't see this test suite. It should be somewhere, but I don't see it. And maybe if I go into samples themselves, maybe samples is the tests. There's tests and samples. No, I do not see tests and samples. Okay. Where are you reading this? That you need to add as platform allow and integration platforms. Where are you reading this? Is this what you're saying? Is this hardware.map? You want me to look at hardware.map? Let's cut map.yum. I'm trying to understand what you want me to do. It's fine. Don't worry about it. 0_q. I don't think this runner is the correct one because it's STM32Q programmer. Because OpenLCD will not run on this board. I think so. Let's see. Yeah, it's fine. Maybe not. We might be able to fix that. Okay. I don't think that runner is gonna work, but let's just see first of all. It wouldn't really work because it's not even in bootloader or unrecognized platform. Yeah. Yeah, platform filter, unrecognized platform. So I'm not so sure what to set there. Maybe it wants us to do the proper board long board name, nucleo. Maybe it wants us to do this. I'm just experimenting. I'm, for lack of a better term, if you would like to know, I'm just fucking about. Let's try that. Let's try the serial. Let's try the serial. Let's try that. Serial. SB means just don't persist anything. That's different. It's already different. Here's where I'm lost. Which test is this running? Which actual test? Where do I go find the test suite that this is running? If it actually runs. That's why I'm lost now. Which test suite is it running? First of all, let's look at serial out. Nothing changed. I'm going to try this one, see what happens. I mean, this looks the same. Let's see. Well, anyways, cool. Yes, we can run tests, and they wouldn't really give us what we want because I either have this terribly misunderstood, or there's a way of, unless you're telling me inside the hello world app, there's nothing is sent to the console. Nothing is actually sent to the console. Let's see. Yeah. Anyways, this was a big question, and when I started building my drivers, when I started building my first driver, it's a battle, and I also wanted like to have unit tests that I ran like normal software unit tests, and I couldn't get them. And most of what I found out is that the way you use tester is to do a sanity build, and if it does build, beyond building now becomes an implementation issue. So, okay, cool, that's much better. But still, nothing on, nothing on, nothing on. So when there's a pin, if I touch it on my. Anyways, let's try this. Let's try it again with bootloader mode. Um, maybe I understand what you say better. Maybe if I just go into bootloader mode and then I flash this or whatever, and then I run it, but I don't see it flashing anywhere. So let's try. I could be missing something. But from what I understand, it's not gonna run it on hardware. It actually makes a report on my machine. It doesn't actually run it on, even though I've gone through the trouble of specifying what hardware to run it on. I don't see it actually flashing anything on my machine, but it's fine. It's okay. We'll know when it says done. We'll just try and reboot and see if it actually gives out Hello World on the console. That would be a good one. If it does Hello World on the console, then maybe. I do know. So I know you can run Z Suite and you can make a actual test application, and then you can run it on your application on your board itself, and then on the board itself you can then let's look here, and then on the board itself you can it didn't do anything. It ran it on my machine. The board was basically not involved at all. Cool. Let's ignore that part for now. Let's go back to our actual GPIO driver and see if we can do something about it. That was a good segue. I'm gonna get someone at work. I'm gonna get Joshua. I'm gonna get Joshua at work to teach me about Twister, and then we'll see if we want to actually implement this. So I'll leave this open. I'll leave that open as well. Because he does a lot of stuff and he contributes to Twister itself. So we'll see. And maybe Twister is a next best thing, and I haven't discovered it. I've discovered a lot of things that way when I was trying to avoid something, and it turned out it was a really good one. Let's see. What do we need to implement in order to have GPIO driver API? So let's Zephyr API documentation. GPIO. Yeah, nothing ever tells us what is the minimum we need to. Nothing says, yeah, this is the same file we're looking at. It doesn't say what it does. They don't actually list out what is the minimum, but that's fine. So cool. Let's actually look at the datasheet and start actually attacking this driver. Maybe even, I don't know. It's already close to 2 hours of experimenting, of not doing a thing, but now I know a bit of Zephyr. I mean, I know a bit of Twister, so it's cool. This is good. It always carries forward. When I learn something new like that, it always carries forward. I never lose. So thank you, Bartholomew. Thank you, Nathan, for all the testing. Let's try and look at this for a couple of minutes, and then we'll see if we keep going or we'll stop and do another session later or tomorrow. So what we want to do is to be able to read the state of the pins, enable the function of the pins, configure the pins. You can, as whatever that is you want to configure it out. Open, drain, push, pull, all of those. You want to be able to configure them, and then read version. Oh, I didn't know that. But that's not what we care about. So we need to be able to write you need to be able to write the GPIO write. The state of the pins defined as GPIO may be changed using the port write function. So this is set 0, set on, set 0, and then you're able to read, and then we're able to enable, and then we can configure. So let's actually see. What is enabling? What does enable mean? Okay, input only. So let's try and follow this. I'll disconnect this guy, put it aside. I'm always happy when I get to play with a nuclear. I'm always super happy when I get to play with a nuclear. So thank you for the chance. Let's actually now do some attacking. Do some actual attacking. This is like broken. This oh no, this is how this shows me where I am. This is just this is a navigation. Nice. Cool. So let's actually look at this this driver, GPIO, SCIM. So they have a we need to just define this. I'm not gonna define this yet. I'll see, and then we'll just go. And then max pins. Where are you using max pins? Where's max pins used? This is for configuring. Cool. Let's actually just follow this and see what happens. Yeah, let's see. I've never used init.h. Let's follow it. Yeah. I'm trying to decide what I want to bring over. So the first thing is I need at least a kernel, I need a device, I need the init, I need the drivers, I need the GPIO and GPIO utils, and I need a logger. I need those. I don't want to copy them. I don't like copying stuff. I already have it. I don't need to copy it. So I'll just go here and I'll start. Okay. R. Okay. Okay, cool. So let's actually start. We put in the compat. So let's now actually start building this driver. So we said I need error number, kernel, device, init, driver. Hash include. This is straight, just error no, h. So I can interpret the errors, and then I wanna hash include what is it I'm including? Zephyr kernel. And then after the kernel I need the device.h. So device, and then after device I need init. And then after init I need drivers GPIO. Zephyr drivers. No. Okay, and then I need GPIO utils. Okay, and then I need the logging framework. And then in here I need to do a log module register. And then in here I need to go like, this is NXP SC1 8IS S606 GPIO, and then this needs to be config GPIO log label. GPIO log. Yeah, so that's the first thing. So that's it included. And then I'm going to need to include hash include. This is going to be, this is where it gets weird. Include. This is going to be SPI, and then in SPI I need to bring, actually no, it's actually like this. So I need to go SPI, and then in SPI I need to bring in NXP, SPI, NXP, oh, no, SPI, SC1, yeah. I can't believe Zephyr is giving me autocomplete on what I want. Cool. Okay. That's fine. I need GPIO max, GPIO pins, GPIO SC1 8IS, SC1 8IS max pins. This is 3. Alright, I like to be that 3. And then let's keep going. I don't need this. I don't need, I'm not going to define this, but I'm going to define all of those. Conf input, those ones. So I'm going to define these ones. GPIO write. Yeah. Define GPIO SC1 8IS write, and this is going to be 0 cross F4, and then define GPIO SC1 8IS. This is going to be, the next one is what? Read F5, read 0 cross F5, and then define GPIO SC1 8IS IS. The next one is enable. enable, and this is 0 cross as F6 if I'm not right, if I'm not wrong, and then configure hash define GPIO SC18IS conf 0 cross F7. Already, we're getting quite far. Zephyr logging. What's wrong? Zephyr logging. This is .h. Okay, cool. What next? Include that. Why is it's not used directly? Fix is available. Don't worry about it. I'll use it just now. Yeah, so let's look at. So we need to make a configuration. We need to make a struct that holds the configuration of the driver, so that later when we are changing things or when we want to set up stuff, we should be able to use the and even in the initialization. So let's actually just do that. So here, the Zephyr doesn't like more than one line, so that's fine. Okay. Struct. I don't know why config has to be fast. I thought the mutex had to be fast, but we'll see why the mutex comes later. So GPIO struct GPIO SC18IS 606 config, and then in here I don't know why this struct GPIO has to be fast. This could be something just from GPIO config, GPIO driver config. This will come from the device API. I see now. Okay. Common. CFG. I don't want to call it common. And then const struct device, and then this is the bridge itself. Bridge. Yeah. And then that's done. And then let's do the data struct GPIO SC18IS 606 data. And then in the data, what do we want to hold? So the driver data, which also has to be fast, struct GPIO driver data. This is so odd because everywhere else you make your own data. Everyone else you make your own. Actually, no. SC18IS 606 data. The name is gonna become confusing later, I know. When we make the macros at the bottom, these names will become confusing. So I just want to specify them like this really well already. I don't know what those confs are, so I'm gonna leave them for now. What is conf1, what is conf2, I do not know. I'm going to leave them out for now. I don't know if I even want to hold an output state. Maybe you want to check what the state is. I don't know. Alright, so I'll leave that out, and then when we do actually encounter something that needs it, we'll see. Okay, now let's keep going. So set row. What does set row mean? set row do? I want to find out what set row means. GPIO set row. Do I actually need it? I don't know if I have to implement set row, and I might actually just ignore all the rows and just go for just set, read, and all of them, because okay. Let me keep going. So I'll see. I'm choosing to ignore the set row part, and I'm choosing to persist with that, because this is it's a very light driver, and someone else can come by later and add that functionality. So I'm okay with the pin configure. I'm okay with yeah, I'm not gonna use get config, so I'm gonna ignore that. I'm not gonna use get row, I'm just gonna use get. And anyways, I see. I see. I might actually implement the rows, because what happens is, I see what's happening. So what happens is, if you this driver is really small, it's already become quite small. So it seems as though if you just implement, I might not implement get config for now, but yeah, I won't implement get config for now because it's anyways in an if. So it seems as though if you just implement set row and you implement configure, and then you're going to implement I'm gonna ignore this, and if you implement get row, all of the other ones just depend on those three. So if you actually implement those three, you can just if you implement those three, you can make all the other ones called those ones. So I was mistaken. I said I was going to ignore them, and now it looks apparently like I'm gonna do them actually, rather than, because if I do them, then I don't have to do any of the higher ones. I can just call downwards to them, and then there you go. The driver's done, basically. Once you see device API and you see this initialization macro down here, the driver's done. So let's walk through set row and stuff of the sort and see what happens. So I want to remove that. First of all, I'm gonna drink water. Does anyone have any questions? So I might need to run. But let me see. Cedro takes a device, which is actually, it calls it a port, and then it takes a mask, and then it takes a value, and then it takes a toggle. And ooh, ooh, that's really simple. That's really simple. That's really simple. I don't want to set row yet. Well, fine. No. Sure. Whatever. Let's actually walk through it. I you want live development? You get live development. Okay. Static int GPIO SC18IS 606 port set row. Oh, it's actually a shortcut to the other one. So you join a const struct device, and this is a pointer to a port. And then here after the port, you want to what do we want to pull in? uint. We want an 8-bit mask. 8t uint 8_t, and this has to be a mask. And then this after the mask, it has to be uint 8t. This is the value. So if I tell you to just set a value, you're going to generate some sort of mask for it. uint 8 t toggle. Let's just see where this goes. And then once we know where it goes, we can just start from there. There's a magic term I'm seeing, but I don't know where it's coming from. Construct GPIO SC18 config. Yep. And then in here from this one, I want to go like just get the let's make this a pointer to the config, and then in here we want to say get port. I see. This comes from the GPIO. This comes from the GPIO subsystem itself. Okay, cool. And this will be filled in by the device tree. Will it? Yes, this will be filled in by the device tree. The device tree will fill in all this information, and then it'll give it to me in the driver. And then when I get it in the driver, I can start doing stuff with it. Okay, cool. It's starting to make sense. Struct. This is the data struct, I'm assuming. Yeah, GPIO. And how come we used config? Why? And then here we want to call it a data pointer because we're going to use it lower, and then equals to port data. So this is all coming from device tree. And device tree, somewhere in the bottom of this driver, we're going to be able to mangle the device tree as we need, and we'll see what happens. So and then we want to take an uint 8 18. This is a buffer, and then we want an 8-bit buffer. It has nothing, and then it's gonna be this, and then I see it has 3 items. So it has a write GPIO, which is a macro, no? So these commands yeah, I understand. So we're making a buffer that we're gonna send out. We're making a command. Okay, cool. And this command is going to be GPIO. Let's see how it works out. GPIO SC1 and then that's it. Yeah, we're making a command. We're now actually constructing a command, and then it's going to be data and then output state. So we want to hold an output state somewhere here. Cool. But how do I... Okay, just a moment. It will come to us. It all comes to us in the end because we want to you int 8 underscore t output state. This is what happens when you just read code and you try and make it yours. So okay, data output state. Okay, cool. And then what do I want? Command stop. We do not have a command stop. Okay, I'll just leave it at that. I'll leave it at that. This is the buffer we're going to set. And then I'm gonna define a return here, int ret. I'm gonna define a return here, and then under the return we're gonna now do some stuff. We can't do k is in ISR. This thing might be blocking. We do not want to. We don't want to do this action if the k is in ISR because this we do not want to. This is why we need. Cool. I understand now. It's all coming together. It's all coming together for sure. So this is why we need error number. And this just needs a comma here. Does it need a comma? Yeah. So this is the buffer we will send, and this needs this is why we need error number, so we can use it like this. And basically here what we're doing is checking that the kernel is not in Bartholomew, help me here. It's not handling an interrupt request. So we're checking that the kernel is not handling an interrupt request before writing to a port, because if writing to a port, imagine a point where you have a some MCUs have like GPIO ports of like hundreds, and you could pick a port with 100 pins and you want to just write out some like 60-bit value to it, and this could take a lot of time, and if it takes a lot of time it would block the kernel, and you don't want to do that. So we check whether this is happening in an this whole operation We're just making sure the user does not do it in an interrupt request, in an interrupt service request. And then if they're not doing that, then we can proceed and do whatever we need to do. Okay, cool. So let's keep going. Let's keep going. Whoa, it looks really simple. And not mask. So just a moment. So we mask it. Okay, buff1, which happens to be the right command. Oh no, this happens to be the one that we're sending, and equals not mask. Okay, and then we just buff, we mask it, and then one, and then we do what? We set it, we set some bits on it. So value and mask, yeah, whatever is set in the value and the mask after we mask it. And then buff1, not, it's what, it's and then we with XOR it with a toggle. I need to understand these 3 lines. I see what the code is doing, but I do not know why the code is doing it. Because we and not mask would take 101, and if you have a mask of 111, and they return it to 010. 010. I don't like this part. But we are all doing this on, we're doing this on only one bit. Bit 1, which is the one that we want to send, not bit 0, not bit 1. So anyways, we will get to it. We'll get to it. So, and then return equals to what is it? SC18IS. Yeah. Y. And then this will take in the device. This will take in the device. This is the device that it wants to use. So the device here is going to be, do they use the port or do they use the new device that they've config bridge? So CFG, and then here take the bridge itself. Okay, cool. And then the buffer is what we are sending. That's fine. It's a 8-bit byte that we're sending. That's okay. And then the length of the buffer that we are sending is going to be size of, yeah. Size of buff, and then RX data. No, we don't send any RX data, so this is going to be a null, and then we don't receive any RX because this is right. I'll show you guys. So this is something we 0, but now I have to go back and read what is ID buff mean. I think this is when we are doing some complex sort of operation that needs, if I remember correctly, I wrote the other function. So sometimes we need to send a function and an ID. Yeah, whenever we want to mess with this, so sometimes we need to send a function and an ID. Function ID. Let's go look at that. Let's go look at this code first of all. I've forgotten it. I wrote it like 3 months ago, so I don't know what it does. It's an SPI. I'm gonna have to stop after this. After this function is done, I need to rush. I need to rush up to the shop and pick my wife up and let's look at it. SPI SC186H. Yep, sure, that's me who wrote that. So let's see. What does this do? Transfer. ID buff. Oh, yeah, here's the documentation. Function ID data if used. Hey, I know what I need to do. His buffer is not going to look like mine. My buffer is going to be different. And I did this so that I don't have to. But here's the problem. Where's output state coming? It doesn't matter. It doesn't matter. Oh, I see. Okay, cool. So this is fine. This is okay. Don't be too scared. And then this ID buff is going to be now the one that we want. GPIO, SC18, right? Yes. Because they're using UART to I2C, so with the packet format for UART is different. You can arbitrarily do stuff, so that's okay. This is fine. What else? I'm now recalling. So that's all that. That's good. Let's actually look at it. So yeah, you build this and you write it like that. Cool. So I built that. I built mine like that, and I'm going to write it like that. Cool. And then just check the state, and then set the output state. Just so the driver can know what it just did, because you might need to use it later. I see. So you do that, and then you set the output state, and then so first of all, let's check if ret. We want to check if ret is less than 0. That would mean we errored out. So let's do that, and then we can do error writing to GPIO. Yeah, we can do that. Log failed to write to GPIO, and then we can do here. We can just show a nice little error here. I'll tell you just now. Nathan, not Nathaniel. I don't know. Maybe you call Nathaniel him. What is Tmax? Yeah, no. I'll explain just now. I know the question you're asking, really. I think Nathan's asking, and then here let's just set the data output state is equals to buff 0. Buff 0. Okay, cool. And then that's it. And then we should return 0. Yeah, I thought that would be a problem. pointer to it. But then take the int itself. Or do you want me to give you that like that? Do you want me to do that? Fine. Let me go see how I've used this function before. I don't even remember. I did write this code. I don't remember. Nathan's asking whether I don't like tmux. It's too many key bindings to remember, I think. And I'm one of those people who can be very obsessive about getting something to work the way they want it to work. And basically what I'm saying is I would waste a lot of time. I would waste a lot of time doing that. And that's not what I want to do, so I choose not to. Yeah, there's this one. Yeah, come. Yeah, let's see how you use it. And this is a null. But there's a place at least we're using it, I'm sure. ID buff. ID buff, function ID. Okay, cool. And function ID here is whatever we want to. When do I need a function ID? This is just for this. So I don't need a function ID on the other side. Why don't I need a function ID? And when I don't need a function ID, how do I do it? Oh, remember I'm sending an SPI message from I2C, so I basically have to build my I don't mind tmux. I think I tried using tmux a while ago, maybe 6 or 7 years ago, but didn't really stay with me. I'm a very lazy person, so I want to do things the easiest way, because once I start doing things the technical way, I can do them too much and then I would waste time, and I don't want to do that. So now where am I sending actual commands? I want to see where I'm sending yeah, config SPI. Just give me here. So buff 0 config byte. So I just do buffers the way I did them before, and it should work. So this was actually in the right way, and this should be a null. It's fine. So this is what happens when you try and remember, when it takes 3 months to merge in some part of code and you forget everything you were doing then. Yeah, and then here I would go like SC18IS GPIO. Yeah. Okay, so what this is doing is it's letting me send a command and then some data after, and I'll show you why I'm doing this. So if you want to write to this, if you want to write GPIO, you would need to write the target address and then you need to write no, let's look at this one. If you want to, this is what we're implementing now. Target address FOH. So target address, right? So this target address is the address of the bridge itself, and then you need it to be right, and then another this is the acknowledge, and then you need to write the FOH, which is the actual command ID. So you see FOH, the command ID, and then the data bit is a uint 8 bit that says which. Yeah, I have to, this all has to be engineered for me. This all has to be engineered for our value. So I need to go through this and actually figure it out, because it depends on the mask, but I can determine the mask from this one. So I'll pass it in, and then the value. So I'll need to, oh yeah. So I have like 3 pins. So depending on which one I want to set, I'll send the correct mask, and then depending on what the mask does. Okay, cool. So it's all covered. Yeah, it's all covered. Yeah, cool. I didn't remember that immediately. Validate it against the mask, and then XOR it with the mask so that it only changes the thing that it's supposed to change. Nothing else is toggled if it's not. It shouldn't be toggled if it should not toggle. It shouldn't be changed if it should not be changed. So that's what we change everything that's not in the mask. We flip the mask, and then we compare what is in one with the mask, and then we XOR it so that it doesn't actually end up changing the things we don't want to change. And then we just we send. This is the actual. This is actually when we do the stuff with the. This is actually when we do the stuff with the thing, with the device itself. See, this is actually how we set the on, if I remember correctly. No. So this is received. That's the function ID. That's fine. That's okay. Yeah. Okay. Cool. I have to stop here. It's been a 2.5 hour, 2 hour 15 minutes of streaming. Do you have any questions right now? Do you have any questions? Close it out. Close this out. Tmax is distracting. VS Code is distracting. AI is distracting. So it takes more time. It's easier to just sit down and write the code and be done for me. So it's not that I don't like Tmax or I don't like all of these things, but the more yesterday I realized I've been writing code for a long time. So I have been writing code for quite a while now. It's even a scary number. It's been almost 20 years of me writing code, and what I've realized is the more you focus on setting up my new Vim is very blank. It's not special at all, I think. And I used to, by the way, I used to do everything I do on Neo Vim in Vim. I'll give you the code for that. I'll go to my old GitHub account. It's my same GitHub account. It actually belongs to my email still. It's just I lost some key and then I couldn't use this account anymore. But it's the same. If you go to something committed by this account, it's still me. So I used to do the same stuff with Vim completely. So I'll show you. It's just new Vim is newer .files. Yeah. So yes, you can say that, but when was this? Yeah, as long as 5 years ago, I still had those. If you go and run Vim with these settings, it will do the exact thing that NeoVim does. So it's not that I actually don't like setting up NeoVim, and I think So this is just if I go here, my yeah, here you go. It's five plugins or something. You'll see. Look, I have LSP for my LSP, Fugitive for looking for stuff. I have Harpoon for doing this. I have Harpoon for doing Control E, Control E, Control E. Yeah, I have Harpoon for this, and then I have what, Telescope for looking through lots of file. I have 3-seater for my syntax highlighting, undo tree for like Control U, Control R, and then I have the completion from LSP. It's my you can find my old setup here. I don't. The most fancy thing I think I'm doing with my I think the most fancy thing I'm doing with excuse me, the most fancy thing I'm doing with my NeoVim is this markdown rendering. So I'm just, because I write notes on my computer. So I want my markdown rendered without sending it to GitHub. But most of my stuff is, my NeoVim is really bare bones. I rarely update it. I'm using like 5-year-old plugins or 2 or 3-year-old plugins, and that's really it. Yeah, it's and I'm using NeoVim because, as I've shown you clearly, I used to use Vim. I just, and before that I was using Vi. So Vim has always been the thing I use, and it's uh, Vim is compoundable, and most other editors are extendable, and the difference is you can add little things into Vim the way you want them, and set them up the way you want them. Whereas with others, you kind of make this way of you make an extension, and then you can't really change it for other stuff than the way you want to use it. Sorry, that was like a little mosquito in front of me. Anyways, thank you so much. Yes, I use NeoVim. It's fine. If that means I like setting up stuff, but I think my thing is very, very, very basic, very, very bare bones, and it just works. And also, I have a very, very old laptop. I have a very old laptop. I think I don't know how do I show that. Um, my computer system, something like that. Yeah. I don't know. I don't know where you see about the system and what it is about. Yeah. So yeah, I have that. A Lenovo T4. It's probably at the very least like a 10, 15-year-old laptop. So I can't. What I'm saying is I can't use heavy editors. My machine wouldn't be able to handle it. It's basically what I'm saying. I've always. So the way I started using Ubuntu was I used Windows until I got to uni. From primary school all the way to uni, I would use Windows. At some point in high school, I did use Linux, but for like a couple of months, if I remember correctly. And then when I got to uni, and I needed to put in, I think it was some Java ID, it was just too heavy. And my dad had just bought me an Acer Aspire notebook. Acer Aspire one. It's just this tiny. It was a laptop like this big, small. And that's what I had in uni, and I couldn't run Windows and run like I couldn't run Windows. It came with Windows 10, but you couldn't run an editor on top of Windows 10, so I couldn't use it for uni. I used to type my notes in uni, and this is long ago. This is before it was cool. Um, Clearly, I make things hard for myself. So yeah, I can't use a heavy editor, so I use a small one, and it works fine, and my machine doesn't overheat, and it's not so distracting, and it works very well for me. And yeah, but I don't. I think everyone can use what they want, and it's cool. At the end of the day, these are all tools, and you can do with them as you wish. You know. But yeah, thanks Nathan. Thanks Bartholomew. Thank you all so much for hanging out today. We got distracted a bit with Twister, but that's the point of this thing. We want to do stuff, and we want to do stuff in a real way. This is not meant to be a scripted video or something. This is just how I do stuff, and it's very nice to have people hanging out with me when I do stuff. That's really it. Thank you for hanging out today. We'll see if we either go on with this driver tomorrow. Yeah, I'll stick on with it, but I have to finish it tomorrow. The thing is, yeah, I have to finish it tomorrow so that we start the new week with other stuff, and we can go back to FPGAs and stuff like that. And I'm just trying to keep streaming at this point. Cheers. Thank you so much for hanging out. See you next time, man.